hear me okay, right? Okay, cool. 844, backspace string compare. Given two strings S and T, return if they equal when both are typed into empty text editors. Um, Hashtag means a backspace character. Okay. Uh, yeah, I think this is just a simulation, right? Oh, when it starts with backspace. Is that a possible thing? I guess so. I mean, so I think the way I would implement it is implement it using I guess this is a case where, I mean, it doesn't start with, but you could get multiple backspaces. But I would just implement this using a stack, and then, well, you do it for the first one, and you get the second one, and then you just compare them, right? So I think that's kind of what I'm going to think about. And then in that case, then your edge case is maybe a little bit easier, because you may think about the buffer as just the backspace is just popping up the top of the stack, right? So that's how I would think about it. So let me go. Let me. I think I'm gonna code this up real quick. Let me know if y'all have any. Yeah, if you have any specific. Like if I'm hand waving a little bit too much and you need more explanation, let me know. Definitely, I love answering questions. It's just that sometimes I just feel like it's, I don't know. To me, it's obvious, and I try to articulate it as much as I can. But sometimes, like sometimes I'm just like, oh yeah, it's obviously this, but maybe it's not so obvious, and I need to explain it a little bit better. And it's not intentional necessarily, so let me know. But yeah, so I'm gonna write a helper method to kind of do it per word. Let's just say, I don't know, get word. Naming is tough. But let's just start with a stack, which we'll implement using an array. And then this is word, it's kind of a word, but you could even look at it as a command list, really. Not a command, but like commands, maybe, where each character is a command. And then you look at for command and commands. And now we could parse the commands, right? And there are only two type of commands, quote unquote. One is if command is equal to the hashtag. Just like I think it's called like an octo 12 or something like that. But 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 anyway, the hashtag. Oh, thanks for the follow, Des. Hope I'm saying that right. I don't know if the underscore is something, but anyway, thanks for the follow. But yeah, so when this happens, we just pop the stack, right? So we just literally do a pop. I think it might actually throw an error if it's empty though, in Python. I've been popping back and forth between languages, which is not great, but it just lets me confusing. But now we could just do if length of stack is greater than 0. Oops. And then I think we could just ignore it. If it's not, then else we push that into it's a pen. Push that into the stack, right? And at the end, we actually just want this. Technically, if you want to look as a pure stack, you want to pop up the stack and then reverse it. But in the way that we implement it, we can actually just return the join version of this, and that should be fine. And then now we just, well, we just check if they're equal, right? And that's kind of see. I think that's mostly right. Maybe I don't think I'm missing an edge case. I guess we'll find out. Now I'm just going to do some testing. I solve it, and oh, I didn't even look at the follow-up, and also the constraints. I would say, usually I look at yeah. Let me submit. Maybe it could be empty. Let me check the empty case. Maybe. I think that should still be okay. I mean, they just return empty cases, but I'd like to kind of check the empty randomness. And if I am not lazy, I would also check the n is equal to 200 ones. But usually those are a little bit more annoying to generate. Unless you think you're going to run into complexity issues, it's not a big deal. Yeah, usually for these type of, for problem solving in general, I recommend, especially on Leetcode anyway. And if you're in an interview, then definitely talk through your interviewers like what the expectation is. But in this problem, the n sub s, you want to call it, the length of s is less than 200 and the length of t is less than 200. But I would also say that if I missed the follow up, to be honest. But I would also say that because the way that we're doing with a stack, because it's O of n, then like I don't have to worry about ends because you have to read the input anyway. So it's not going to be that much faster unless you're doing some kind of like binary search where you don't need to put it in put everything in memory and so forth. So yeah, can you do it in O of n time? So this is O of n time and is O of n space because we use a stack which could get O of n. I might. Can I do an O of one space? Let me think about it real quick. I don't know. I mean, I think I would say you could maybe do it in O of one space and weird if you do multi-pass, because you could keep track of number of future hashtags. I forgot what they call it. But future commands, and then maybe kind of do something so that that it's not like some sort of weird like forward-looking count, because you only have one command, right? So you essentially you know how many of these are coming. So then in doing that, you could do some math to kind of know if you need to print or not, or you have to kind of keep track of it a little bit. And then you could kind of do like the two fingers algorithm type thing, like almost like a sliding window. I think you could probably do it that way, but that's really unnecessary for this problem, maybe. And maybe not. Maybe I shouldn't say that. But that's definitely something that I would think about in general. Yeah, and using substring, technically you have maybe O of n number of substrings, but yeah. So I would say this is given a stack problem. I would definitely recommend studying this, or at least practice this, not study, just because that is very much in the realm of an interview question. So I would definitely whether I believe it is a good interview question or not. This is like a very trivial use of it. Yeah. So the question is that so the question is how do we know that we needed to use a stack for this problem? And the reason I need to to the stack is that, well, I mean, I'm going to try to articulate it a little bit. To be honest, the way that I got to that point is just by intuition and experience a little bit, which is a cheesy way of saying it. I mean, I'm not justifying it, and now I'm going to try to articulate that. But the reason that I think about that is because for each command, for each non-alphabet, you have to look up one space, and that's just very similar to how the Polish notation or the other one. I always forget the note. I get confused about the notations, but that's the one where you have an operator. In this case, the operator only reverse Polish notation. There you go. Thank you, Max. That was so nice to see you. But yeah, I was thinking about those lines, which maybe is not it's not an introductory look at it, but that's how that's where my mind went. Where like, well, this command, if you will, applies to one previous character, which is to pop it off the stack, right? And I think that's the way that I need to know is that because given a command, I know that it only needs to look at one previous. Like, I mean, and some of this is that obviously we all typed on a keyboard before, so we know what a backspace is and how it reacts. Like we backspace twice, it gets rid of two characters and so forth. So there's some like intuition there, from real life, and I think that's kind of the way I would think about it. And the only thing that I would think about is kind of what Quo was saying earlier with an empty string. And well, stack is actually, we implemented in line 9, and that allows us to kind of handle it very cleanly. I think you could play around with something that because I think you could do n squared very easily. especially since n is 200, where you like go backwards and then get the last character that isn't used or something like that. But in doing that, you just get the idea that, like, if you visualize that, the naive algorithm of n square of like, okay, you keep on adding stuff to a string, and then you hit a hashtag, and then you go back to the last one that isn't used, and then you either remove it or mark it as used. I mean, in theory, they're the same way. And then from that, you just notice that, well, once something is removed or marked as used, then you never use it again. And that's very similar to a stack. And I think a lot of that is just doing enough stack problems, perhaps, and kind of being familiar with it. And then once you realize you could do it up to one string, doing it to the other one, I hope, is a straightforward extension. And then just checking to see if they're true, which is literally what the question asks you. So I would, like as I was saying, I think I definitely can see that this is a problem that interviewers will ask. So definitely prepare for it. For comparative programming, this is pretty basic stuff. So I think, definitely worth doing. I hope that answers your question. Cool. Do I have anything else to ask about this? No. And this I don't know if I described this. I mean, this is O of n. So and the reason is because we look at each character once, and once more if you want to counter that for printing it at the end, and maybe a third time if you want to be really pedantic about it for string comparison. Cool. I mean, I think so definitely my school of thought about learning it is kind of that classic. But my school of thought about learning is just try to really understand what the fundamentals are and kind of think how you apply for different things, right? Here, and I think the way that I would think about it, and I do this actually on slightly harder problems, and sometimes, or like very often even on stream, is that I kind of try to draw it out like different scenarios, and for me, like you get like A B C D E, and then you draw like some hashtags, and you try to think about what that means, right? Well, these two they match, and then the second two they match, and so forth. So I try to think about it that way, and then I try to think about different data structures that kind of and different techniques that allow me to kind of simulate these rules, and a lot of that is just experience and practice, experience from practice, because I think for me, the TDD approach, but I think one thing that I would say is that start from just, I think it's very like the ideal, quote unquote, the ideal way to solve these problems is just be like, okay, here's the problem. Okay, now this is obviously X, Y, and Z because I use algorithm X and then I do algorithm Y and then solve it that way, right? But I think another approach that I recommend just for practice is that the approach that I recommend for practice is just kind of think about almost create a checklist of the algorithms that you're comfortable with. Let's say in this case, let's say you have a stack, you have a queue, you have maybe breadth first search, and then go through it one by one. Just do it as an exercise. Be like, hey, okay, I have this problem. Can I do this with stack? If so, how do I do it with stack? Okay, I mean, well, in this case you do. But let's say you have another way, like okay, I try to do it with a queue, but like a FIFO queue, and then you're like, how can I make this work with a queue? And then in doing so, not only do you, well, one is that in doing so, you I think for me anyway, I still learn in that case, in that I don't necessarily learn what the right answer is, which is great, obviously. But I also learn what are the limitations of a queue, for example, right? Like in this case, can I use a queue? No, because like you never do anything with the first character, and like if you try to do it in a weird way, like maybe you reverse it in the end, and then it ends up being like, okay, maybe there's a cleaner way to do it, right? So I think for me, and this comes up for me personally more often when I do like greedy problems, because very often with greedy problems you try to do it in, or maybe not greedy problems, but just like problems that could be greedy or may not be greedy. But I try to do them in greedy. I'm like, okay, maybe I'll just do greedy on this properly, and then I kind of dig into it, and then I'm like, wow, it's really hard. Like I maybe it's not greedy because there's this special case, and well, why does this special case make it not greedy? Oh, because you have an assumption of substructure optimality that's based on this thing, this property that's no longer true because you have to go across a different boundary or something like that. I'm like rambling a little bit, but I think for me, especially when you really, it's yeah, you need to figure, or you should, get comfortable with both figuring out how to solve a problem, but also how not to solve a problem, if that makes sense, and learning the limitations of certain algorithms and data structures and so forth. And that's what it means to be like really understanding things. Because if you ask me like a similar question, I'm like, why wouldn't you use a priority queue? Then I could also explain to you as well, ideally, right? I mean, maybe this one is a little bit too weird, or like it's obvious why you would use a priority queue, but for certain other problems, I think I would like to get